And hi everyone, my name is Rauda Masita binti Ghazali and my metric number is 100849. Today I'm excited to introduce you to our project on emotional intelligent music mood detection. Let's start by talking about the impact of music. As we all know, music has profound effect on our emotion. It can uplift our spirit, calm our mind, or even intensify our feelings. In today's fast-paced world, understanding and responding to this emotion has become increasingly important. Whether you're feeling joyful, sad, or stressed, the right music can make a significant difference in your emotional state. Now, let's move on to our aim. Our goal with this project is to develop a music system that brimming with emotional intelligence. What does that mean? Our system listens to the user mood through their text input and then recommends Spotify tracks that reflect on how they're feeling in real time. Imagine typing in how you're feeling and instantly getting a playlist that resonates your current mood. That's what we are aiming to achieve. So, what are the key benefits of this system? This approach ensures a listening experience that is not only personalized but also deeply connected to the listener's emotional state. By doing this, we enhance well-being by reducing tension and boosting positive emotion, like having a personal DJ who knows exactly what you need to hear. Alright, let's dive into how it works. Our system revolves around three main components. First, emotion detection. Our system uses a pre-trained bird model to accurately classify emotion from the text input provided by the user. This model helps us understand the user's emotional state with high accuracy. Next is music mapping. Once we have detected the emotion, we map this emotion to specific music genres. For example, if you're feeling happy, we might suggest you some upbeat pop song. Third main component is secure integration. We use Spotify Owl for secure user authentication and access to Spotify extensive music library. This ensures that the system can seamlessly fetch and recommend songs that match the user's current mood. Our system is designed to adapt emotional shift, offering music that matches the user mood in real time. This not only provides comfort and joy, but also has the potential to improve mental well-being through tailored playlists. By bridging the gap between emotion and music, our technology fosters a deeper connection between the listener and their music. Looking ahead, we plan to develop a more user-friendly graphical interface or GUI to make the system even more accessible and enjoyable to use. Additionally, we're working on introducing advanced personalization feature based on user history and preference. This means the system will adapt to your current mood while also considering your personal music taste and past listening habits to better recommendation. That's all for introduction. Thank you.
Hello everyone, my name is Veronica binti Anthony and my choice number is 101271. I will present my part which is motivation. Music has always been a powerful medium for expressing and evoking emotion. Our system has to look at different sounds and how the body reacts to guess how a person is feeling. And things like the beat of the music, how fast or slow is it, and the tunes and how they all is fit together can tell a lot. Now, by knowing what mood you are in, music systems can pick or change songs to match just how you are feeling. A person could calm and shooting sounds to help ease their mind into a state of peace. Not only that, what we got from motivation from mood detection, personal touch and connecting. Music always be a system that know how to read emotions, get better by paying attention to what user speak and say. By making the music feel more personal, it draws the listener in closer. This makes the listener feel really good and happy inside. The role of mood detection at the core of emotionally intelligent music lies mood detection. It can also play a role in therapy and wellness too. Emotionally intelligent music finds it can be a place in helping with therapy and wellness too. Music therapy stands as a recognized method for helping with healing, reducing stress, and fostering better ways to express feelings. Machine learning and artificial intelligence has made big leaps forward in creating music that can understand our feelings. Creating tunes that match how we feel more closely. In addition, a few issues and thoughts to think about. Critical issue that must be addressed all through the development and deployment of EIM system include privacy concerns regarding the collecting, legal issue about controlling emotions through music, and the demand for strong validation of emotion detection algorithms. Detection lies in making the music experience better tailored to each person, making it more personal helping, which therapy, making the most of new take advantage and dealing with any problems that come up.
Artificial intelligence and music can be combined to create emotionally intelligent music system, which can identify and respond to the emotional content of music. Mood detection, which allows people to recognize and classify emotions in music, is a crucial component. The primary techniques, resources, and uses for mood detection in this system are examined in this work's analysis of pertinent literature. When it comes to identifying musical mood, machine learning, particularly deep learning models like RNNs and CNNs, performs admirably, surpassing more conventional models like random forest and SVMs. Model detection research has evolved quickly thanks to public data sets such as the Million Song Datasets, GTZAN, and DEAM. The basis for emotion recognition in music was established by studies in music information, retrieval MIR, and music psychology. The emotional impact of musical aspects such as rhythm, timbre, harmony, and tempo was studied in early research. Theoretical groundwork for computer models of mood detection was done by Gisling and Sloboda 2021 and Graf-Wilson 2002. Application for mood identification in music include recommendation apps, interactive art, and therapy, cultural differences, emotional subjectivity, and music intricacy provide challenges. Subsequent studies should integrate models that solve these problems, make use of larger datasets for improved generalizability, and employ multimodal data for accuracy. The identification and quantification of audio signal components of feature extraction is a crucial component of mood detection. This can be divided into three categories: low-level MFCCS zero crossing rates, spectrum characteristics, mid-level homograms, rhythm patterns, and high-level lyric analysis, mood text, and etc. It is common practice to extract low-level characteristics using libraries such as Labrasa. Advances in mood detection research and emotionally intelligent music have made tailored to emotionally charged listening experiences possible. To completely incorporate music and emotion into daily life, these systems need to overcome two significant challenges.
Our software is a novel application that recommends songs based on users' mood detected from their text input. It uses Spotify API for personalized music recommendation and a pre-trained BERT model to classify emotions from text with high accuracy. The software analyzes user-provided mood descriptions and and suggest songs accordingly, integrating securely with Spotify for user authentication and access to its music library. There's a key features. The first one is emotion detection, which utilize Transformers library and the Patrish 70 Best Go emotion model for high accuracy emotion classification. Second one is music recommendation, maps detected emotion to music genres. For example, happiness to pop and sadness to blues to suggest suitable songs. The third one is authentication. Uses Spotify OAuth for secure user authentication and access to Spotify vast music library. Challenge overcome including first one, integrating Spotify API with secure authentication and achieving reliable and efficient emotion detection.
Hello, today I will be sharing appendix. So this code sets up a system that recommends a Spotify track based on the user's real-time emotional state, which is inferred from the text input. So the first code is importing necessary libraries, the OS for settings, environment variables, Spotify and Spotify OAuth for interacting with Spotify's API, pipeline and transformers to load a pre-trained emotion detection model. Setting up Spotify credentials, the Spotify API credential like Spotify client ID, Spotify client secret, and Spotify redirect URL are set up and stored as environment variables. Spotify client ID, you can get it from the website, Spotify website, after you made an app on the API website. Is authenticating with Spotify authenticates the app to access to Spotify. Function to get Spotify recommendations. Get Spotify recommendation based on mode. This function maps a detected mode to a music genre and fetches a song recommendation from Spotify. It uses a dictionary to map modes and genres and calls the Spotify API to get the track recommendation based on the genre. Loading the emotion detection model. Emotion classifier and ethyl model Pradesh Savani or bird-based Go emotion. This line loads a pre-trained BERT model for emotion detection. And function to detect emotion is on detect emotion. This function uses the loaded model to detect the primary emotion from the input text. Function to suggest a song based on the mode. Suggest song based on the mode, the description. This function detects the emotion from the input text, gets a song recommendation based on the detected mode, and returns the mode, song names, artist names, and Spotify URL. Example usage. The script takes user input for their current mode description, detects the mode, fetches a song recommendation, prints and detected mode, along with the song details with a Spotify link. I will be showing the output of the code for Spotify. So the program prompts the user to describe their current mode. For example, the user might put the word happy, and then after we write happy on the terminal, then we enter it, the emotion detection will work. The code uses the detect emotion function to analyze the input text and determine the primary emotion. For example, the detected emotion might be joy or happy. The next output is the Spotify recommendation. Based on the detected emotion, the Get Spotify recommendation function maps the emotion to a music genre and fetches a song recommendation from Spotify. For instance, if the detected emotion is happy, the genre might be pop.